What's up guys? Science Garage here. And what you are looking at right now is Schlieren Imaging, wherein you can make the invisible visible. Curious to how it works? Let us jump into the garage and show you the setup and concept of Schlieren Imaging. Our first setup involves a concave mirror, an LED that has been made to imitate a point light source, which is directed to the mirror, and as the light from the LED reflects, at the point wherein the light focuses to a point, we put a razor to cut off half of the light that goes inside the lens of the camera. The razor cuts off half the light being reflected, creating a light and dark spot on the image on the camera. This allows the camera to see the slightest differences in refractive indexes of substances being shown in front of the mirror. The first setup was easy, but we had a hard time with it because of the equipment we had was too small and harder to set up, and it shows in the images captured with the setup. The second setup is much simpler, with the use of a plane mirror and the concept of reflected pinhole photography. We placed the mirror far enough until the reflected light on the wall forms a circular shape and the image being shown is sharp. Then we place different objects 2-3 feet away from the wall and the results are amazing. Schlieren is a way to see what we normally can't see, through the different refractive indexes of light when it passes through different materials. Variations in refractive index caused by heat or pressure causes distortions in the light being reflected at the camera. This distortion creates a spatial variation in the intensity of the light, which can be visualized by the camera in our first setup but can also be seen by the naked eye with our second setup. This type of imaging is used in studying aerodynamics and fluid flow, as it allows them to see the differences in pressure, density and temperature of the objects they are observing. We hope you learned something new. This is the Science Garage signing off.